about controlling the physical world with Bacnet and the Bacnet attack framework. Basically a set of tools for controlling buildings, kind of like the one you're in. So stay tuned. Basic disclaimer, of course, everything I say is my own personal opinions, not those of the employers. Hopefully education, a little bit of entertainment purposes. This is a work in progress, hence why it is one of these types of talks. Still a lot more to do. I am not an expert on Bacnet in any way, shape, or form, but as we go through, I think you'll see there's some fun stuff. You'll also see that from my code, I am not a developer. So at the end, I have a shameless plug looking for those of you out there who have Python skills. And of course, above all, if you guys are going to use any of the tools that are talked about or that are part of this attack framework, pen testing framework rather, don't go full tard. Make sure you got the right permissions. All right, who am I? Well, my name is Brad. I'm this guy who likes to play around with technology. Okay. So, my name is Brad. I'm this guy who likes... This guy likes to play around with technology. I know a bunch of you in the room. For those of you who don't know me, you don't care who I am, and that's okay. But if for some reason you do, you can throw me into Google and you can figure it out. All right, so what are we going to talk about? Well, first off, I'm going to talk a little bit about what Bacnet is, specifically around Bacnet IP. I know some of you have a pretty good understanding of it. Others may not have ever heard of it before. So we'll go a little bit into that. We'll talk a little bit about where Bacnet is used and a little bit about the architecture. And this is to try to funnel things down, really to get you to a point where you can understand what some of the risks are, and then, of course, the attack surface. And at the end of the day, show you a set of tools that are written in Python to actually exploit, test, or assess some of these types of systems. And, of course, open up for Q&A as we go. So first off, what is Bacnet? Well, Bacnet stands for Building Automation and Control Network, and at its simplest form, Bacnet is the communication protocol that is used by building management, building automation, and SCADA systems. You can think of Bacnet as the TCP/IP that's controlling all these things, different sensors, and I'll go into them in great detail, but it is the part below the SCADA system. So we've seen lots of really good talks and really lots of good stuff dealing with what can be done with SCADA systems. I'm focusing my stuff on the gateway devices that control the endpoints, and I'll get into that. Building management controls, lots of different equipment in a building. I'll give some examples. It was really designed to pull lots of disparate systems, so things from Honeywell, from Siemens, from pick your major vendor that's out there that does either valves, HVAC, elevators, and so on. It's to be able to pull all those together. So again, it's kind of analogous to TCP/IP in my mind. It doesn't care what's on the endpoint, as long as you're talking this common protocol, it will allow you to control it, manipulate, and get some data. There's lots of interoperability with Bacnet. It's Assura, I think that's how it's pronounced, standard. Basically what to take away from this is a Bacnet environment, like the one that sits in this building, is the same as a Bacnet environment you would see in Europe, or in Iran, or in China. Not suggesting targets, I'm just throwing that out there for your edification. Basically, it's also a culmination of lots of different protocols, and we'll hit that. So where's Bacnet found? Well, you typically, in the years past, Bacnet was really found in more of the metering or reading parts of it. Basically reading power meters, water meters, HVAC, electrical, and the list goes on and on. Well, what's kind of changed is that now Bacnet's being used for more control, being able to use a SCADA system or a building management system to control things such as elevators or fire suppression. As an example for some of the fire suppression stuff, these things control things like if you have a data center that is still using halon or something like that, it will prime the pipes. It will tell or send out triggers to have elevators in a building go down to the ground floor. It will make doors unlock in some instances to try to allow people to evacuate a building in a timely and easy fashion. You see the Bacnet stuff used in intelligent lighting. This is becoming really popular because of the cost savings involved. Smart elevators, and the list goes on and on. So basically, it provides an element of sensory measurement and control. And control is where things start to get interesting. Highly complex or highly sensitive systems are being controlled these days via Bacnet IP, or the building management systems that control them. Carbon monoxide detectors, pressure safety valves, fire suppression, and the list goes on and on if you do some Google searching for it. But basically, most large structures these days have some form of building management system that they are using to control lights, plumbing, heat, electrical, elevators, and those types of things. You can find it in factories, plants, some residential housing over 55, what do they call them, senior community housing places are starting to use this. And the types of deployments are really starting to grow. So here's a high level of what a Bacnet network kind of looks like. And the stuff you see at the very top are the things that we're used to seeing. These are the building management systems, the SCADA systems. These are the systems that our admins or facility workers are used to putting their hands on to read and control. That device that you see in the middle, the blue, that goes by a lot of different names depending on which vendor you talk to, but basically it's called a BBMD device, Bacnet Broadcast Management Device. Some vendors call it a router, some will call it a gateway, and some call it a couple other things. All the things you see on the periphery are the types of things that it is controlling, reading, getting information from. Gas, electrical, power, some lighting control, some elevator control. The picture I have on the right of the screen is to really just send home a simple message. Most of these things are simple microcontrollers, right? Just a very small, simple computer. And those of you who know me know I'm a huge fan of microcontrollers and making them do things that they weren't intended to do. So for my stuff, I'm really focusing around these components. The BBMD device that acts as that gateway or routing component, as well as the actual objects or endpoints that are at the bottom. Why? Well, because there's been lots of attacks that happen at the top layer where an end user is controlling a SCADA system or a web server or something like that. Not a whole heck of a lot of stuff really focusing on the guts of it inside. And when you see what some of the weaknesses are, you'll understand why I'm looking at that. Okay, so a little bit about the architecture. Well, Bacnet has a pretty simplistic architecture setup. Devices have a set of simple collections of objects and services that manipulate things. So by standard, there are 23 of these objects, and there are 9 of these services. And I won't read them off to you in the sake of time, but basically, you control these various objects with the services. So with the service, you can say, write a value, read a value, delete something, create something, whatever it may be. And for those of you who are Bacnet experts, I know there's many, many other ones that are out there that are proprietary for certain vendors. These are the most common ones, so I put them in there. But the device in the center, this BBMD device, is what kind of acts as the brain. It allows all these disparate types of network topologies, such as Modbus or master-slave token passing or serial connections, to communicate over a standard TCP/IP type of connection that comes out of the backside of this. So these become kind of that central routing or gateway point. I said 2 components that really want to focus in on just a little bit. I talked about the Bacnet gateway device, or these routers or broadcasting equipment. They store 2 things that are kind of important for us. One is called the BDT, or Bacnet Device Table. What that table is basically a listing of all the objects, valves, controls, HVAC sensors, temperature readings, that kind of things, that are understood and controlled or are providing that information and sending it up to a building management or SCADA system. The other one is called the Foreign Device Table, and what this one does, it's kind of the equivalent of allowing one router to talk to another. Basically, the Foreign Device Table are systems that are pre-approved to be allowed to talk to one of these gateway devices. Something that it's allowed to request information, something that's allowed to control route, and something that's allowed to collect other pieces. So all this, of course, is done over UDP. So right now, your spider senses should be tingling. Think of all the vulnerabilities associated with UDP that we've looked at and played with over the years. This is where some of the attack stuff comes in. All right, low power microcontrollers. These are some of the reasons why I think this is important. The vendors are really, really good at what they do, but microcontrollers really, it's not their forte, so they have problems built around them. The Bacnet IP stuff uses a UDP quasi-looking stack, but it very closely resembles UDP packets and datagrams. So this gives us the ability to spoof things, to inject traffic. Since there's no session control there, all the things that we could do with some of the old legacy UDP stuff, we can do here on these Bacnet devices. We don't have time to get into the 3 Mile Island incident, but if you look at some of the YouTube videos about what happened at 3 Mile Island, basically these guys in the control room were getting a sensor that was reading off to them. Based on what they thought that sensor was saying, they made a chain of mistakes or errors that caused a kind of a domino effect that caused a potential or a partial meltdown. It's a really good kind of thing, and it puts things into context when you think about, well, what could somebody do by just making a sensor look like it's going when in fact there's not a problem. So another reason why we should care is, I know some of you are thinking, well, it doesn't matter because no one would put any of this stuff on the internet, right? This is all inside a building. Wrong. Unfortunately, one of the tools I include within the Bacnet attack framework is a tool to go out across the internet and try to identify Bacnet environments that are out there. Now, this is actually much higher. The last time I did this, I think it came out to 20 or 30 something sites. Now we're up to 62. So unfortunately, just like everything else that you know about, people do stupid things and put them on the internet. All right, so we talked a little bit about what Bacnet is, what it does, a little tiny bit about the architecture. We talked a little bit about what the issues could be. We need to talk about the attack surface. What's our potential for doing something? So weaknesses, of course, in the structure are the BBMD devices that we went into. I won't go over the BDT table and the FDT table. Most of the communication that is done here, it has no authentication, and that's really where things start to get a little bit tricky. Another thing is that Bacnet devices don't have a real MAC address. They actually use their IP address that you provide and a common source port, 47808, to do all of their communication. So these are the things, of course, that are very easy for us to manipulate from a packet perspective. It makes the ability for us to control things a lot easier. The equipment was meant to be in the back room and just doesn't seem to happen that way. Interesting, if you look at the Bacnet diagrams and information, one of the first things they say is, oh, don't make sure you never allow this stuff to be on the internet or facing anything that's outside because of the potential risks. All right, so the Bacnet attack framework. So basically, I have a collection of tools that break down into 3 categories. The first one is discovery, second one's enumeration querying, of course, some of the spoofing capabilities, and the last one gets a little bit more nasty. All these tools are done in Python 2x. All of them use the standard libraries you would find on any backtrack machine with the exception of the Nmap Python that you need to pull in. I did all this on a backtrack machine, so I know it worked there. It works pretty good on Windows boxes. I'm trying to go as quickly as possible. Again, the tools here do not focus around the SCADA system. So if you were to use any of these Python scripts and try to attack the web component or the database that makes up the building management or SCADA system, it's not going to work. That's not what these are intended for. All right, so let's get into it. The first one is Bacnet ARP sweep, and this one basically just does a discovery. Not only will it tell you Bacnet devices, but it tells you everything that's on the network. Pretty straightforward. The next one is Bacnet Scanner. Now this one looks specifically for Bacnet devices. It uses the unique signatures that they typically have, which is that UDP 47808. Hence, this is why I'm using the Nmap libraries for Python. For those of you who've done UDP scanning, you know some of the complexities of trying to get real results. This was the best thing. I figured I wasn't going to write anything better than the Nmap piece. And which I missed something in the last slide that I wanted to say. All of these tools are built around the Scapy library. I don't remember the guy's name who created Scapy, but that is the coolest stuff for doing any kind of packet creation or packet generation stuff. So next one's Bacnet Sniff. I'm going to talk more about that in the following slides, and of course Bacnet Search. This one uses a very popular search engine to identify certain websites that could be hosting Bacnet devices. All right, so Bacnet Sniff. Basically what this tool is, you give it an interface and it will collect all of the Bacnet packets that are being seen on the network. The nice thing here is that it gets rid of all the other network noise. Thank you. It will only pull in Bacnet IP packets. If you've used Scapy before, you've seen this. It puts packets in a very nice breakdown. It discerns all the pieces that you want, color codes it. This does get dropped down into a PCAP format, so if you're looking at lots of traffic, you can import this into Wireshark should you want to at a later date. All right. I think I went too far here. Hold on. There we go. So the next part of tools start to get a little bit more interesting, and this is where it gets into the enumeration of the end devices and starts spoofing packets. Well, the first one is IM device. So Bacnet has this packet that allows you to create or act like you are a Bacnet IP entity. You could be a valve, you could be an HVAC detector, you could be an elevator. So you get to pick what you want to do. This allows you to create some of the different types of packets. Bacnet Query allows you to interrogate any existing ones that may be already on a target network. And here's some examples, but basically the framework allows you to just change the bits a little bit and the flags to make it so you can do darn near anything that you want from that perspective. So to get just a tad bit nastier, the next tools are IM router. Now, if you remember, I was talking about the BBMD device. Well, basically, this one sends a very unique packet called a Bacnet virtual link something. And what this one does is it tells other Bacnet routing gateway devices that, hey, I'm a Bacnet router too. Share all your information with me. Allow me to communicate and control the devices that you're responsible for. So if you're a pen tester, this could be very handy because now you can interrogate all the devices that are stored within the primary gateway or BBMD device. It allows us to also pull the foreign device table so we can actually act as an entirely different router altogether. Foreign device tables were really designed so if a company had multiple facilities in like a campus environment, that they could have multiple of these BBMD devices, all allowing them to kind of communicate between each other, not only from a high availability perspective, but to share data. The next one is confirmed alarm. This was kind of interesting, and I'm not 100% sure why this works, but Bacnet's got this piece that says, I'm going to send you a high priority packet. And what happens when it gets this, the device says, okay, I'm going to ignore all other traffic, and I'm just going to focus in on what you want me to do. It doesn't take a lot of imagination to think what you could actually do with something like that by actually eliminating all the other communication. A problem is also in some cases, these types of packets tend to make the valve control device or metering device fall over to the point where someone has to physically walk up to it and push a button to get it back alive. The next one is Bacnet spoof, and this basically just allows you to do a form of fuzzing. Since they are low-cost microcontrollers, they're not really apt at dealing with malformed or corrupt packets. They don't know what to do with them. So this allows you to manipulate all the different little flags within the packet stream, throw them down the wire, and use your Bacnet sniff to collect all that traffic coming back and see what's going on with it. And of course, the last one's a lowbrow Bacnet flood, and the idea behind this one is very simple. DOSing a unique device. You can either set it up to DOS the gateway device or an individual sensor. So if you want to become the elevator controller or a controller that's changing the exhausting of a building's HVAC system or the temperature, you could basically set something up that would just make it look like that device is gone, you're now that device, and everything that the SCADA system receives and reads, and everything that the building management system, from a controller perspective, what that end user is going to see is actually not going to be coming from the device, it's going to be coming from you. So it allows you the ability to completely spoof some of those pieces. And here's just some of the examples. If we had more time, I would try to do one of the live ones. But here's an example of it, sending the packets, crafting it up, and becoming a BBMD device, becoming that router, so you can actually control all the devices that are associated on that particular network. So I had all these individual scripts. What I've been doing is rolling them all up into something that I call the Bacnet pentest or attack framework. So this way it's just one script that's menu-driven, and as I get new things that seem to kind of fit well, I'm adding them into this as time goes on. All right, so something real quick for the pen testers. All the packet stuffs are packed in raw binary, a little EDN format, of course. Malformed packets can and will render some Bacnet devices inoperable. So if you're a pen tester and you decided to do this against a building, not this building, please, but if you were to test it against a building, you want to be careful what you're doing because it can make them stop responding. I've also learned that your typical modern laptop will actually crush these things. They simply can't handle the speed at which your normal laptops can generate packets, so be aware of that. And of course, Wireshark will decode all this stuff also. Turns out Wireshark does have a plugin, or what do they call it, to allow you to decode Bacnet packets. All right, so what's next? So my goal for this thing is really to try to continue to build it out from a spoofing perspective. For those of you who know me, I'm really big into Arduino, so I'd like to make a pen tester version that is just an Arduino with an Ethernet shield and a micro SD. You plug it into a network and it pulls in all the information, and then they can just go back and analyze it. So shameless plug here. If you guys know Python and you're really, really good at it, especially with packet generation stuff, I could really use some help. Please just see me or hit me up. If you know Bacnet and you know Python, I really, really could use your help because there's still so much more to be done here. The code will be available up on Digital Intercept. or if once one of my guys teach me how to use GitHub appropriately so I don't have to worry about it getting popped over. And I think with that, questions. Anything, going once, going twice. All right. You want to get a hold of me, there's the contact information. Thanks, guys. Did I put you back on schedule?
Yes.
Okay, perfect.
All right. Thank you very much, Brad. And would Phil Young please self-identify?